Welcome back to Math for Technology. Thus far in this chapter we've been working with vectors, and specifically the vectors have been able to be turned into right triangles, or we've been able to use the shortcut to get to the answer. We're going to now work with non-right triangles, which are called oblique triangles, and we have to have another tool in order to work with them, because the Pythagorean theorem only works with right triangles, which we don't have anymore. And the basic 3 trig functions, or 6 trig functions, work with right triangles as far as opposite, adjacent, and hypotenuse. So the new tool that we have is called the law of sines, and its basic form is shown to you here with the idea of this proportions. And notice there are 3 different sets, 3 ratios that make up this proportion. So I can either work with the ratio of the A's, the B's, or the C's. So the idea that the opposites are still holding true, even if it's a non-right triangle. So wherever I put A, B, and C angles, the opposite sides are their little a, their little b, and their little c. So they're still paired up. Okay, and that's these pairs here. This law of sines was developed by you taking right triangles and breaking them up and being able to work with them. Since the formula was already developed, I wasn't going to go through that. If you want to know for sure how it was developed, let me know and I can get you that information. We're just going to go ahead and practice using the tool. So our first example is we're going to solve this triangle. And previously you have solved triangles, and solving, remember, just means find what you don't know. So in this case we don't know side A, side B, or angle C. And no longer can we say that angle C is a 90-degree angle, because these are oblique or non-right triangles. So I'm just going to sketch out what I think the triangle looks like. I'm going to make this angle B, since it's a little bit bigger than 90, angle A and angle C. I'm going to go ahead and mark things in the proper spot. So this would be side B, side A, and side C. We know that angle A is 20.5 degrees, angle B is 96.4 degrees, and side C is 33.2. Now, just like before, triangles still only have 180 degrees. It doesn't matter if they're right or not. So finding angle C is not a big deal. We're just going to do 180 minus. I'm going to go ahead and organize this before I get too crazy with solving. I know that A is 20.5 degrees, B is 96.4 degrees. I'm going to find C. I'm going to find side A, side B, side C is 33.2. So to go ahead and find angle C, we're going to go 180 minus 96.4 minus 20.5. So we get an angle of 63.1. Now what that also did, with using the law of sines, we have to have a pair, and so in this case my pair is I know everything about C. I know its angle and I know its side, and that has to occur in order for me to use this tool. So I'm going to go ahead and set up what I know. It's side A over sine of angle A, side B over sine of angle B, and side C over sine of angle C. Now what you may notice is this is simply a proportion, and so we can solve proportions. And I'm actually going to ignore the A here, and I'm going to work with the C's and the B. And since I only have one unknown, I can go ahead and think back to how I solve a proportion. I'm going to cross multiply. So B times sine of 63.1 equals 33.2 times sine of 96.4. Now to get b by itself, I need to divide. So I'm going to go ahead and divide by sine of 63.1. Now I've created the habit of trying to be exact all the time. So instead of finding out what 33.2 sine of 96.4 is and then dividing, I just plug all of this into my calculator at one time. That allows me to be accurate. Just make sure when you do the sine of 96.4, go outside of the parenthesis before you tell it to divide by the sine of 63.1. And when you plug it in, you should get that b is approximately, and try and keep your answer since the c is to the nearest tenth. You want your answer for b to the nearest tenth. And I got 36.996. So to the nearest tenth is actually going to round all the way up to 37.0. Now you might be thinking, okay, let's do the Pythagorean theorem, but remember this is not a right triangle, so I can't use the Pythagorean theorem. So instead I'm going to do another piece of this law of sines. What you can do now is ignore the b and use the 33.2 sine of 63.1 and the a and sine of 20.5. So I'm going to slide over to the side here. And so what I'm saying is I'm going to do a over sine of 20.5 equals 33.2 over sine of 63.1. Again, I'm going to cross multiply. So I have a times sine of 63.1 equals 33.2 times sine of 20.5. I'm not going to use my calculator yet. I'm going to go ahead and divide by sine of 63.1 on both sides. So a is equal to this. So I'm going to plug all of this into my calculator. 33.2 times sine of 20.5, get outside of my parenthesis, divide by sine of 63.1, and to the nearest tenth I get 13.0. Now one of the other things you can do is you're looking at your answer to kind of verify if you're doing on the right track. The smallest angle, which in our case is A, should be the letter that matches it should have the smallest length. So 13 is definitely the smallest length. The angle B is 96.4. Its side should be the longest side, so 37. So smallest angle is the smallest side, largest angle is the largest side, and then the middle angle is the middle side. So that works. So I feel very comfortable and confident that that's my answer. So we're going to go ahead and try that again. I notice this time I have two sides and I have an angle. So I do have an obtuse angle, so I'm going to go ahead and make an obtuse triangle. This is 108, which is angle B. So this must be side B, which is 26.4. It doesn't matter who you make A and C. Just make sure whoever you make A that across from it is side A, and then that would be side C there. So I don't know angle A. I do know angle B is 108. I don't know angle C yet. I know side A is 25.3. I know side B is 26.4. And I do not know side C yet. I can tell that I know everything about B, so that's going to allow me to do law of sines. So I'm going to set up the proportions. So it's 25.3 over sine of A equals 26.4 over sine of 108. Now, I didn't continue because I don't know anything about C, so I'm going to leave that alone for a minute. So what I see here is I only have one variable, that's the A, so I'm going to go ahead and cross multiply. So 26.4 times sine of A is 25.3 times sine of 108. In order to get the variable by itself, which is the A, and remember sine is stuck with it, we're going to divide by 26.4. Okay, now I'm going to go ahead and do the division and the multiplication. 25.3 times sine of 108. Get outside the parenthesis, divide by 26.4. So what happens here is I have sine of A is 0.9114 blah blah blah. So this isn't my answer. My angle A is not 0.9114. I have to find the inverse of sine in order to find the angle. So on your calculator, do the inverse sine 0.9114. I got angle A is, I'll go ahead and write it up here, 65. I'm going to go ahead and go one more decimal, even though the 108 is a whole number, 65.7 degrees. Since I know that that is 65.7, I can go ahead and find angle C by doing the 180 minus. So angle C, 180 minus 108 minus 65.7. And I have an angle of 6.3 degrees for angle C. Now I'm going to do this proportion again to find side C. So I'm going to use the same one. I always try and use the one that I have that's the same all the time. So 26.4 and sine of 108. Then I'm going to use side C, which I don't know, and sine of 6.3, which I just found. So we'll do our cross multiplying. So I have C times sine of 108 equals 26.4 times sine of 6.3. Divide by sine of 108. So I'm going to plug this piece in. 26.4 times sine of 6.3 outside the parenthesis, divide by sine of 108, and I get a measurement of 3.0. So again, look at your numbers. Smallest angle is across from the smallest side, largest angle is across from the largest side, middle angle is across from the middle side. So we're good to go with our answers. Okay, let's go ahead and look at example 3. Looks like we have a situation. 2 high-tension wires are to be strung across a river. There are 2 towers A and B on one side of the river. These 2 towers are 470 meters apart. A third tower C is on the other side of the river. So let's go ahead and draw so we can see what's going on. So here's my river. It says 2 towers A and B are on one side of the river. Tower C is on the other side. Let's go ahead and create the triangle between them. The 2 towers are 470 meters apart on the same side. The third tower we don't know anything about. Angle ABC, so that means that it's at vertex B. So this angle is 67.4 degrees. The angle BAC, so the one at A, is 50.4. What are the distances between towers A and C? A and C, that would be little b, and between towers B and C, which would be little a. That's what they're asking us to find. So I can go ahead and find angle C first, because I'm going to need that so that I can have a match. So I'm going to go ahead and organize it, even though they're not asking us simply to solve it, but to find particular things. It'll just help me know I have it all. So I know angle A is 50.4. I know angle B is 67.4. go ahead and find angle C, 180 minus 50.4 minus 67.4. $62.2. Now the reason I needed to do that is, remember, I know side C is 470, so that's my pair that I have my match, and I can use that to find both A and B for the sides. So we're going to go ahead and do that. So let's set up, find angle or side A first. So A over sine of 50.4 equals, it's my degree sine, 470 over sine of 62.2. Do our cross multiplying. So I have A times sine of 62.2 equals 470 times sine of 50.4 divide by sine of 62.2. $470 times sine of 50.4, close the parenthesis, divided by sine of 62.2. I end up with a distance for side A of 409. Now I'm going to do side B. So that's going to be B over sine of 67.4. For the other one, I'm still using my C's or my pair. So that's 470 over sine of 62.2. We're going to go ahead and do our cross multiplying. So I have B times sine of 62.2. I'm actually running out of room. Let's move that. Since you already have your stuff written down, I'm going to move this out of the way so I have some more room. So we're going to go B times sine 62.2 equals 470 times sine 67.4. Divide by sine of 62.2. 470 times sine of 67.4. Close the parenthesis. Divide it by sine of 62.2. And I have 491 approximately. So let's check. This B is my biggest angle. 491 is my biggest side, so those match. Angle A is my smallest angle, and 409 is my smallest side. So to answer the questions they're wanting, how far between towers A and C? That's 491 meters. How far between towers B and C? That's 409 meters. Okay, that's how we're going to use it to do this using the law of sines. Go ahead and work on your assignment. If you have any trouble, let me know.